Hi everyone and welcome back to a new episode of BWD. Today we're gonna code a program to display the matrix rain. By the end of the video, your program will display exactly what you see on the screen. But on top of that, you will be able to change how the rain looks by tweaking the parameters of the program. And you know what's the best part about it? No external libraries to run this program. Python code only. If you're new to this channel or you're back watching this video, do not forget you can find timestamps in the video description below. And all the code that you're gonna see in this episode is available on GitHub, link in the video description below. And now, without further ado, let's get started. Before jumping straight into coding, let's go to the board and have a look at how the algorithm is gonna work. So let's start with a very basic question. How can we make it rain? Well, a simple idea might be to fill the screen with Japanese characters and then drop some of them. So for example, we start with a full screen and then we draw yellow boxes. And then we're gonna drop all the characters found there. Alright, pretty easy. But this is something static, right? How can we make this move? As we've seen in episode number 2 of this series, to make something move we have to create a sequence of frames, or in other words, a video. So if you've never done this before, I highly suggest to go and check episode number 2 before moving ahead with this video. Alright, what we're gonna do is to create a sequence of frames. At each frame, we're gonna add and drop a new row. Let's see how we can do this. Let's take for example frame number 1. Right after it, we're gonna display frame number 2. But this one is gonna be a little bit different compared to frame number 1. As you can see, the last row is not the same. The last row in frame number 2 is exactly the row preceding the last row in frame number 1. So what we're gonna do when we move from one frame to another is to drop the row at the bottom. On the other hand, we're gonna add a new row at the top of the new frame. So for example, when we display frame number 3 here, we can see that the last row is not the same, and that's because we have to drop the last row in frame number 2, and at the top we're gonna get a new one. Okay, now we're left with another question. As you can see, every new row has both Japanese characters but also empty slots. So how do we get to decide whether to display a new character or an empty space on a new row? Well, to give it an answer, we have to define two types of elements. Let's define an empty sequence as a series of consecutive empty slots. On the other hand, we're gonna call a sequence a series of consecutive characters. Great, and now let's focus on both of them. The first idea is really simple. The longer the sequence, the higher the probability that the sequence is gonna stop. To better understand this, let's see a simple example. If we focus on the very first row at the top, we can distinguish between two scenarios. For example, in the first column, the character in the very first row is an empty slot. On the other hand, if we look at the third column, we can see that there is no empty slot, but rather a new character. So the difference here is that the sequence keeps going. So every time that we're gonna display a new line at the top, for each sequence, we're gonna calculate the probability that this stops or not. And as we have just seen in this example, even if two sequences have the same length, it might happen that one stops and the other one keeps going. So if we draw the probability of this happening, it will look like something like this. In this graph on the x-axis we have the length of the sequence, or in other words, the total number of consecutive characters. As we can read, the higher this value, the higher the value of the probability that we can read on the y-axis. For example, here we can see the probability approaches 1 when the length is 5. On the other hand, when the length is 1, the probability is almost 0. If we focus now on the empty sequences, we can think of a similar idea. Specifically, the longer the empty sequence is, then the higher the probability that a new sequence will start at the next new line. So also here, if we have a look at this example and we focus on the very first line, we can distinguish between two scenarios. In the first one, after 4 consecutive empty slots, a new character pops out. In the very last column instead, even if there are 4 consecutive empty slots, a new empty slot is displayed on the new line. So what we're gonna do here is similar to the previous example. Every time we display a new row, we're gonna compute the probability that an empty sequence stops. And if we draw it, this is gonna look like something like this. However, here notice that on the x-axis we have the length of the empty sequence. Alright, these are all the ideas that we're gonna use to implement the matrix rain. If anything is not clear, don't worry. As we start coding this, I'm sure that everything will be easier to understand. And now it's time for coding it. As first step, we're gonna try to fill the screen with characters. And for doing this, we need the size of the screen. So let's import the US module and use the getTerminalSize to get both the number of columns and rows. However, for now, let's fill only half of the screen, so let's divide both of them by 2. Next, let's define the characters constant. This is gonna be a list holding all the Japanese characters, but for now, let's just fill it with numbers and a few letters. Now we're finally able to fill each row, and for doing this, we need the random module. That's because for each column of each row, we're gonna pick a random character. And we can do this by writing a list comprehension within another list comprehension. In the inner one, we're gonna loop over the number of columns, and in the other one, over the number of rows. Alright, and now let's use the system function from the US module to clean the screen, and right after, let's display each row. And finally, to display each character one by one, let's use the sleep function. Alright, let's give it a try in the window below. This is not what we want, right? As you can see, each character is displayed on a new line. Instead, we would like to have one next to each other. To fix this, we can pass to the end parameter of the print function double quotes. Ouch, something is not really working here. As we can see, no characters is displayed at all. But why is that? If we shut down the program, we can see that something weird happens. Before the exception error, we can see that there are actually some characters, and they are displayed next to each other. So why does Python display the characters only when we shut down the program? That's because by default the print function keeps the data in memory and displays them only when a new line character is found. However, here, a few seconds ago, we've just modified the default behavior of the print function. And that's because we've passed to the end parameter double quotes, whereas by default, this is equal to a new line character. So in practice, what is happening here is that Python is collecting all the new character that should be displayed, but because no new line character is passed to the print function also, the print function keeps all these characters in memory, and as a result, never displays them. Luckily, there is a way to fix this issue. What we have to do is to change once again the default behavior of the print function, and this can be done by passing to the flash parameter true. As we can see, now it works. So I have briefly touched on this topic, but if you wanna know more, just look at the references in the video description below. Alright, and now let's try to print row by row. But doing this is really easy. We have just to move the sleep function out of the for loop, cycling over all the characters found in each row. Great. As you can see though, after each row is consumed, the program shuts down. Instead, what we would like to see is a sequence of frames. And to do this, we can write a while cycle, which will go forever unless the user shuts down the program. Alright, exactly what we wanted. And now let's drop these numbers and add the Japanese characters. Exactly like we have done in episode number 7 of this series, we're gonna use the char function and pass to it all the numbers corresponding to the Japanese characters. So if you have never seen how the char function works, I highly suggest to go and check episode number 7. Then I'm sure that everything will be crystal clear. Now, before trying this out, I think that the screen is updated a little bit too fast. So let's increase the time that we wait in the sleep function to 1 second. Great, it works. Let's see now how we can color the characters. Let's open a Python interactive shell and let's define the dark green color. So now you may wonder, but what is exactly this sequence of characters and numbers? This is an ANSI code or an ANSI escape sequence, and it's out of the scope of this video to go into details of this. So if you want to know more, you can check out the link in the video description below. For this video, let's just say that you can use ANSI code to define colors and pass them to the print function. So for example here, if we try to print a simple string like matrix, we get it white. However, if we pass the ANSI code to the print function before the string itself, then the print function recognizes the ANSI code and displays a colored string. Pretty simple, right? So now if we try to print the string again, as you can see everything is green. So keep it in mind that when you use ANSI code, it's like you are changing the default behavior of the print function. Everything from there on will be displayed by the color defined by the ANSI code. And of course, it's possible to go back. In that case, you have to pass the ANSI code of the original color used by the print function. In this case, white. Now, before we code this in our program, I want you to focus on something here. Do you see any difference between the output of these two print statements? As you can see, in the first one, there is an empty space between the string matrix. But why is that? Well, the thing is that the print function will recognize any ANSI code you pass to it, and it will change accordingly its behavior. However, any ANSI code that is passed is also displayed as an empty string. That's why we can see that empty space. Luckily, fixing this issue is pretty easy. When we write the print function, we have to pass double quotes to the separator parameter. And as you can see, even if we pass an ANSI code, no empty space is displayed now. Alright, let's define the three colors that we're gonna need as constants. If you wanna use different colors though, you can simply check out the codes on the internet. Next, let's update the print function, but for now, let's pass it only the dark green. Great, it works. However, as we can see, there is spaces between the characters. But we know why that happens. We didn't pass the double quotes to the separator parameter. Great, and now the only thing left to do is to figure out how we can create sequences and empty sequences in our program. So the basic idea here to figure this out is to define a variable to keep track of the number of consecutive characters. When the number is higher than 0, then we're keeping track of a sequence. For example, if it is 5, then there is a sequence made of 5 consecutive characters. On the other hand, if the count variable is minor than 0, let's say -3, then we're keeping track of an empty sequence made of 3 consecutive empty slots. Pretty easy, right? And now let's go to the board and make some examples to better understand it. When we spin the program, the very first frame is displayed immediately. And now let's suppose to zoom on a target column. As we can see at the screen, an empty slot is displayed. So what happens when we spin the program is that the count variable is equal to 0. Then, because an empty slot popped out, the count variable is updated, and now it's -1. And that makes sense because we know that in this column there is an empty sequence made of 1 empty slot. Next, frame number 2 is displayed, and what happened is that the very last row from the previous frame is shifted down by 1, and at the same time a new line is added at the top. And as we can see here, again an empty slot pops out. Okay, right after the count variable is updated, and now is equal to -2. And this makes total sense. There is an empty sequence made of 2 empty slots. In the next frame, however, a new character is displayed instead. And what happens is that the count variable is updated, and now is gonna be equal to 1. That's because a new sequence has started, and this is made of 1 character only. At frame 4, we can see that a new character is added, so also this time the count variable is updated and now is equal to 2. So this keeps going, and every time the count variable is gonna be updated. And now let's fast forward to frame number 8. As you can see, there is a sequence made of 6 characters, and indeed the count variable is equal to 6. At the next frame, however, we can see that the sequence stops. So what happens here is that the count variable is updated, but now we are back to the negative numbers, and specifically, count is gonna be equal to -1. That's because a new empty sequence has started, and this is just 1 empty slot long. Alright, as we've just seen, the count variable is a simple but yet powerful way of keeping track of the sequences in each frame. However, there is another important tweak that we have to do to get this program working. In our explanation, characters do not change from one frame to another. However, this is not how it is supposed to work. In fact, for each sequence, all the characters are gonna be different if we compare one frame to the next one. So in practice, what we're gonna do at each frame is to fill the screen with Japanese characters. Then, as we will keep track of both the position of the sequences and the empty sequences, we're gonna color each character accordingly. So for example here, all the characters in the yellow boxes are gonna be displayed as black. To better understand this, let's go back to the previous example and focus again on a single column. At frame number 1, an empty slot is displayed. This implies that we are actually displaying a character there, but that is black. That's why it appears as an empty slot. So what we're gonna do right after updating the count variable is to update another variable that we're gonna call color. And here we're gonna add the black color of that character. And by adding every time the colors to this variable, we're gonna be able to keep track of the position of both sequences and empty sequences. At frame number 2, another empty slot is displayed. This implies that we're gonna add another time black to the color variable. At frame 3 instead, a new character pops out. This entails that a new sequence has started, And as we know, the very first character of any sequence is gonna be always light green. So what we're gonna do is to add light green to the color variable. Next, at frame number 4, another character pops out, however this time is gonna be colored dark green. That's because all the characters of any sequence are always gonna be dark green, except for the first one. So again, if you fast forward this to frame number 8, there's gonna be a sequence made of 6 characters. However, at frame number 9, this sequence stops. That's why we're gonna add black to the color variable. Okay, great. If this last part is not clear, however, don't worry. As we start coding this, I'm sure that will be easier to understand. But if you have still some doubts after all, just write it down in the comment section below, and I will answer right away. Alright, let's start by defining the count variable for each column in the screen. That's why count is gonna be a list, and in each element we're gonna hold the value for each column. Of course, at the very beginning this is gonna be 0 for all of them. And right after, let's define the colors variable as an empty list. Now let's update the to-for cycles. The difference here is that at every iteration we're gonna loop over all the colors of each row. So the r_c here stands for row colors, and the c_c variable stands for character color. Now let's code the part responsible for the sequences and the empty sequences. Every time that we enter the while cycle, a new row is added at the top, and what we're gonna do is to calculate whether a new character or an empty slot is displayed. So first of all, let's define the new_colors variable, where we're gonna save all the colors of the new row. And to get each color, we have to iterate over each column. Next, we have to compute the probability based on the value of the count variable for that column. So it's out of the scope of this video to go into details of this formula. What matters for us is that from this one, we're always gonna get the probability of the sequence stopping, or, on the other hand, of a new sequence starting. And then we're gonna use it to generate a random event. So let's go to the board one last time now to figure out how exactly we're gonna do this. Every time a new sequence starts, or on the other hand an existing sequence stops, we can think of them as a random process. And a simple yet powerful way of visualizing this is to think of a random process like a bag with some balls. For example here, let's suppose to have an empty sequence made of one empty slot only. As we know, the longer the empty sequence, the higher the probability that a new sequence will start. So in this case, if we pull our hand in the bag and we get one ball out of it, then we're gonna have one chance out of 10 to get a green ball. If we get it, then we can think that a new sequence starts. Otherwise, the empty sequence keeps going. When the empty sequence is 2 slots long, then there are gonna be 2 light green balls and 8 black balls in the bag. So again here, if we pull our hand and we get a ball, then we have 2 chances out of 10 to get a green ball. And we can keep doing this. For example, when the empty sequence is 3 slots long, then there are gonna be 3 light green balls and 7 black balls. Or in other words, the probability is equal to 0.3. Another way to look at this is to start from the probability and then create the composition of the bag. For example, when the probability is equal to 1, then we know for sure that all the balls inside the bag are gonna be light green. And this is exactly what we're gonna do in our program. Once the probability is known, then we can create the bag, and right after pull our hand there and get a ball out of it. In this way, we're gonna be able to generate the random sequences needed to display the matrix rain. Alright, and now let's get this done. Let's start by creating the bag. Whenever the count variable is minor or equal to 0, then we're dealing with an empty sequence. And to create the bag, we're gonna write down a list comprehension made of 100 elements. And the distribution of these elements will be equal to the probability of a new sequence to start. So let's say that the probability is equal to 0.4. Then in the bag there are gonna be 40 light green and 60 black elements. And this is exactly what this list comprehension does. The only thing that you have to pay attention is that the probability that you see in the formula is not equal to 0.4, but is gonna be equal to 40. And why is that? That's because in the formula for the probability above here, we multiply the result by 100 to get exactly a number between 0 and 100, which is needed to get the list comprehension working. Alright, the same idea applies also when we have to simulate whether a sequence stops or not. So let's write down another list comprehension. The only difference here are gonna be the colors, which are gonna be black and dark green. Finally, as a last step, we have to pull our hand in the bag and get a ball out of it. And to do this, we're gonna use the choice function from the random module. Alright, finally we have the color. Now it's time to update the count variable. And we're gonna do it by writing a series of if-else statements. So whenever the color is light green, it means that a new sequence has started. Then the count variable is gonna be equal to 1. That's because the new sequence is just 1 character long. On the other hand, if the color is dark green, then we're gonna update the count variable adding +1. That's because the existing sequence is now 1 character longer. On the other hand, if the color is black, then we're dealing with an empty sequence. So if the count variable is higher than 0, then it means that the new empty sequence has just started. And that's why we're gonna set the count variable equal to -1. But if this is not the case, it means that the empty sequence has already started, and now it's gonna be 1 slot longer. That's why we're gonna add it -1. Alright, now let's not forget to add the color to the new color variable. And when we're done iterating over all the columns in the row, let's append the new colors variable to the colors list. In this way, in the colors variable, there are gonna be as many lists as many rows in our screen. Finally, let's make sure that we display only the colors of the row that should be actually displayed. So in practice, we're gonna drop the very first element of the colors variable whenever the total number of elements in the colors variable is higher than the number of rows on the screen. Alright, we are almost ready to go. Before trying this out, let's fix a couple of things. The first point is that whenever we are adding a new fresh row, then we are using the append method, which means that the colors of this row are gonna be the very last elements in the colors variable. But when we display the Japanese characters, we start from the very first rows. So in practice, what we have to do to match the color with the character is to apply the reverse built-in function to the colors variable. Next point is to increase the number of frames displayed per second. And to do this, we're gonna reduce the time we wait in the sleep function. Finally, let's not forget to import the math module, which is used in the formula for the probability variable. Alright, and now let's give it a try. Alright, here we go, we finally got the rain working. The only thing that we have to fix now is that the rain stops in the middle of the screen. But this is gonna be pretty easy. Let's drop the division by 2 when we calculate the number of rows. However, we won't do the same for the number of columns. And why is that? Because the Japanese characters are actually 2 columns wide and not 1. So if you don't divide by 2, then it won't work. And now it's time for enjoying our matrix rain. Okay, we have finally come to the end of this video. If you have any question or feedback, just write it down in the comment section below. Do not forget to give it a like and subscribe to the channel to not miss next week's episode. In the meantime, if you wanna do more, just check the GitHub repo, where you can find the next steps for this exercise. And with that said, see you in the next one. Ciao!